So this is section 5.3. You already have a section on the quadratic formula, which you should watch prior to watching this video. It's a section deriving the quadratic formula. And remember that the standard equation for a parabola is y equals ax squared plus bx plus c. And this represents a quadratic. That's the definition of a quadratic equation. And when we do the quadratic formula, when we derive it, what we're actually finding is x-intercepts. And x-intercepts will be very important from now until forever, because as far as your math careers goes, because so many times in calculus or higher math, you're trying to figure out where this equation is crossing this line. Those are x-intercepts. Now, in this case of a quadratic, you know, you just have this up and down motion, bam, all right? So you have those two x-intercepts. They're very helpful. That's why the quadratic equation always gives you two answers, is because a parabola, oh, okay, it could give you no answers. Let's go over that real quick. So the quadratic formula, there's three possibilities. First, we could have the standard parabola, voila. And it only touches right here at one place, so it touches once. Okay, then we have a parabola that maybe is like this. And it's going to touch the x-axis twice. That's two touches, right? But we could also have a parabola that is sitting up here, got pushed up or whatever, and this doesn't touch at all. These are three scenarios. The quadratic equation, when you solve for this and you use the quadratic equation to get your x-intercepts, the quadratic equation, the answer to the discriminant can tell you which one of these it is. So that's a lot of words that don't make sense to you yet, so let's go over what that means. So we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's talk about this very quickly. This right here is the discriminant. All right? The discriminant is not just used right now. It's used other places as well. The same idea as this discriminant, something that tells us more about the picture than we can tell by just looking at the equation. So this little piece of the quadratic equation is going to tell us lots of stuff. Let's imagine that piece, this discriminant, let's imagine that the discriminant equals 0. That would be easy. Let's say that when you add b squared minus 4ac, that this number equals 0. So what would this whole thing come to? It would be the opposite of b plus or minus the square root of 0 over 2a. What is the square root of 0? 0. So what does this really equal? The opposite of b over 2a. How many answers did I get? I got one answer. When the discriminant equals 0, you have one answer. And what that means is that it is sitting right there on the axis, like this. It only touches in that one point. I'm only going to get one answer for that x value. There it is. Bam. One answer. All right? Now let's imagine that it equaled -4. Let's put that in there. The opposite of b plus or minus the square root of -4 all over 2a. What would that give us? That would give us, well, so far, and we're going to learn how to deal with these, but we haven't really dealt with them yet. That's going to give us an imaginary number, because when you take the square root of a negative number, you get an imaginary number. And we're going to deal with that later on. But the idea is that imaginary numbers, if you got, it's going to be the opposite of b plus or minus 2i over 2a. If you thought regular numbers were hard, they're about to get harder, because now they're going to become imaginary, which sounds really funny. But the idea with this is that there are no touches. This parabola will not touch the x-axis. If this is the x-axis here, it's not going to touch it at all. It's the quadratic equation tells you where an equation crosses the x-axis. If it doesn't cross at all, you're going to get crazy imaginary answers. Okay, that's just what that represents. And lastly, let's imagine that there's actually a positive number there, positive number. So let's say let's say that it equals positive 9, okay? So b plus or minus the square root of 9 all over 2a. Well, what's that going to give us? That's going to give us the opposite of b plus 9 over 2a and the opposite of b minus 9 over 2a. I'm basically taking this plus or minus and I'm separating it up into two solutions. So x could be this, or x could be that. It gives me two answers. I get two answers. And they're real answers, as opposed to two imaginary answers. My writing just went south. Okay, now, it's possible to get, like, instead of having the square root of 9, which is, I can't take the square root of 9, look at me. The square root of 9 is 3. All right, so let's imagine we have this, let's say, what if it equals a positive 7? Well, I'm still going to get two answers, but they're not going to be rational. They're going to be irrational, because I would have like the square root of 7 in that answer. And if the square root of 7 is in an answer, then it's not rational anymore. So remember, if it's a perfect square, you're going to get a nice, rational, clean answer. If it's not a perfect square, you're not going to get a rational answer, but you still will get an answer, a viable, true, valid answer. So you need to be able to understand what the discriminant is and what it represents. If I were to draw a picture of a discriminant with one answer, it's going to sit, it's going to be touching the x-axis at one point. A discriminant with an imaginary, with a negative, when you take the square root of a negative, where the discriminant is negative, that graph never touches the x-axis. And if you look at one that's positive, that graph would touch the x-axis in two places, like so. So it doesn't tell you everything about the graph, but it tells you quite a bit. The discriminant will give you an idea of whether or not that graph touches the x-axis. All right, so that goes over the discriminant, and you'll find all that information starting on page 183. It starts talking about the discriminant, then it goes into the conclusion, which is the nature of the solutions of a quadratic equation. You need to know what the discriminant is. You need to be able to identify it in the equation. You need to tell me what it means. Does it mean it have any roots? Does it have real roots? Does it have imaginary roots? Are there rational roots? You have to be able to answer those questions. If you can't answer those questions, you need to re-watch that first part of the video. So, let's do example number 3. We have y equals x squared minus 5x plus 3. Now what they want us to do here is find the vertex. So I'm just going to write down over here what I'm looking for. I'm looking for vertex. I'm looking for x-intercepts. And I'm looking for the y-intercept. And I want to get its symmetric point. So they're only looking for one symmetrical point. I'm fine with that. Okay, so let's just go with the y-intercept first. Remember, when you're looking for the y-intercept, what it really means is that x equals 0. What happens when x equals 0? I get y equals 0 minus 0 plus 3. So the y-intercept is 3. Okay, so how do we find the vertex? Well, the vertex is found by putting this in vertex form. So let's go ahead and do that. I'm going to say y minus 3 equals x squared minus 5x. I need to complete the square. So my coefficient in front of my x is 1, so I'm golden. Now I'm going to take half of this, which is 5 halves. Always work in fractions when you're completing the square. Do not move to decimals. Fractions are your friend, unless I tell you specifically, use your calculator and use decimals. Do not use decimals, use fractions. So when I square this, oh, it's a negative 5 halves, by the way. So when I square negative 5 halves, what do I get? A positive 25 fourths. So now I need to add 25 fourths to this side as well. So I'm just going to squeeze that in, 25 over 4. So minus 3, that would be 12 fourths plus 25, so this is y minus 13 fourths, or sorry, plus 13 fourths, equals x minus 5 halves squared. I'm going to go ahead and erase this little note to myself so it's cleaner. All right, so I have this in vertex form, which is y minus k equals a times x minus h squared. I'm already in my right form. So what's my vertex? My vertex is hk. So that will be 5/2 and negative 13/4. I'll take a look, see at what they've got there for the vertex. Yeah, they're using decimals. That's ookie. Don't do it. All right, now we want to find the x-intercepts. What does it mean to find an x-intercept? It means that the y equals 0. Because remember, every time a graph crosses the x-axis, y is equal to 0. So we're going to go ahead and do that right here. We're going to say 0 equals x squared minus 5x plus 3. Well, hooey, I can't factor this. But, although I can't factor it, I can use the quadratic on it. So remember, on the quadratic, a is whatever's in front of x, which would be 1. B is whatever's in, or I'm sorry, a is whatever in front of x squared. B is whatever in front of x, so that would be a negative 5. And c is this number, 3. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and fill that in. The opposite of b is 5 plus or minus the square root of 25 minus 4 times 1 times 3 all over 2 times 1. So that would be 5 plus or minus the square root of, this is 12, so 13. So that means that if I'm looking for my x-intercepts, I'm going to go ahead and move this down because I need a little bit more space for it. My first one will be 5 plus the square root of 13 over 2, 0. My next will be 5 minus the square root of 13 over 2, 0. Now, the last thing they want is a symmetrical point. So what we have to ask ourselves is, right now our y-intercept is the point 0, 3. I'm going to erase this over here so I have some space. So this is what we have so far. Let's just draw it. So 5/2, of course, is 2.5. Negative 13/4 is about 4 1/3. No, 4 1/4. So here we are. If my y-intercept is up here, right, I came back 2.5 and up here to 3, high. I'm still going to do the same thing. It's going to be the same height over here somewhere. So basically, here is 2.5, okay? I went back 2.5 to get to my y-intercept. So I'm going to go forward 2.5, and that will put me at 5, 3. That gives me a symmetrical point of 5, 3. Now I've listed all my information, just like they have. You just systematically go through, find the vertex, find your y-intercept, find your x-intercepts, find the symmetrical points. Done. It should be a process. All right. Lastly, I think this is the last part of this, is talking about the vertex of a parabola and what the axis is, like they're trying to tell you how to find the vertex, how to find h. What they're really giving you here is how to find the axis of symmetry, and I'm going to tell you why. So let's imagine that this parabola did this. I don't know what this point is, and I don't know what this point is. But where is the vertex? If I knew what these points were, where would the vertex be? Well, remember, a parabola is symmetrical. I can fold it. So if I were to fold this, my vertex would be exactly halfway in between those two intercepts. And if I took this halfway point and I put it into the equation, I'd figure out what the y value that matched that was, and I'd find that vertex. And that's what they're telling you right now. They've got this formula here. So again, remember, a parabola sitting here, it doesn't really matter where it is, if it's over here. If I have the 2 points, by default, the vertex has to be right in the middle, smack dab in the middle of those 2 points. So let's say this was 1 and this was 4. Let's go with 5, okay? So if this is 1 and this is 5, then my vertex is at 3 something. Oh. It's at 3 with some y value. Well, if I actually had the y squared equals, ax squared plus bx plus c, and I actually knew what these numbers were, I would just plug this 3 in for my x and all the places, and then bam, it would just come alive, and voila, I would have my y point, and I'd be done with my vertex. So the question becomes, how can I figure out where this axis of symmetry is? Well, the axis of symmetry on a parabola is the squared. So if we have y minus k equals a x minus h squared, this is the squared variable. This h is my axis of symmetry. At x equals h, at that line would be the axis of symmetry. Now later on you're going to do equations where you actually have y minus k squared equals x minus h, and it's going to be flipped where the y is squared. In this situation, for these, and you're going to do these a little later, your graph actually goes sideways like this. So your axis of symmetry now is actually a line that, in this situation, would be y equals k, would represent the axis of symmetry. So understanding what the axis of symmetry is, and that it always goes through the vertex of a parabola, is important. All right. So now the question becomes, how do we find out what h is? And they're giving you a formula, h equals the opposite of b over 2a. Well, doesn't that look familiar? Because remember, when we complete the square, if we have ax squared plus bx, right, plus c, and we have this equal 0, we kick this c out right away. That comes over here. Oh, it's gone. All right, and then what do we do here? We have to divide through by a. So we say a, we have to factor that a out, plus b over ax, right? And then how do we do this? We take half of this, which is b over 2a, and we square it, right? And we go on to b squared over 4a. And we keep going just like that quadratic thing. But when we factor this down, we get a times x minus b over 2a. This is your h. That's what h equals. It's the same, it's coming from the same place. They represent the same thing. So when you want to use the shortcut to find it, you just take, so let's do they're saying calling it a shortcut. Really, it's just understanding what you're doing. So they give you the equation y equals 7x squared minus 29x plus 37. This is what they give you. Ugh. Not very tidy. Okay, so here's what they have. So my a is 7, my b is negative 29, my c is 37. Well, they say that h equals the opposite of b over 2a. So that must equal the opposite of b, which is 29, divided by 14. So once I know what this is, I take this value right here. I'm sorry. Did I copy that down wrong? Minus 27 minus... Oh yeah. The opposite of b here is negative 29. Yeah. Okay, good. Yeah, they have a positive. They have the same thing. They just go into decimals. I hate decimals. Ugh. Okay, but if we were to take this x value, so we know that our vertex, the x value is going to be 29 over 14. We don't know what our y value is. But to find our y value, we just take this and we plug it into this x, and we plug it into that x, and we multiply it out. And when you do that, You can plug that in your calculator, that's fine with me, I get it, those are big numbers and blah. You're going to get a number out, and that number will represent the Y value of that vertex. These are extremely important things. I think we're watching the videos multiple times is good. If you have questions, please, Daniel, get with John or tell your mom. I will make more videos about this. It's imperative you understand this really well. You too, John. But you get to talk to me when I go home at night.